All right, number 2, we want to identify which of the following are exponential functions. Let me show you the definition in the textbook. So if you go through the textbook, you'll get to see a lot of details, concepts. I'm mainly going over how to solve the problems and giving you examples in these videos, but here's the definition. B is a constant, a real number. It's greater than 0, not equal to 1. And then it says for any real number x, the function of the form b raised to the x power is exponential. All right, so that's the definition. Which of these apply? Well, right here we see negative 4.9. Now we were just told b has to be greater than 0. This being negative does not work. This does not have the x in the power position. It's just 2 times x. That would be a linear function. We need it to be in the x position, or the not numerator, but exponential position. Third option works, 4.1 greater than 1, raised to the power x. This one does not work because the base where we have x has to be a constant, a number, and this is a variable, which means it will be changing. So that one does not work. And square root of 4.6 will work. That will be greater than 1. It will be positive. So the third and the fifth options work. All right, number 3, we're going to use the function below to answer the following questions. Use transformations of the graph 2 to the power x to graph the function. Write the domain and range in interval notation, and write the equation in asymptote. Write the equation of the asymptote. So let me show you from our course in our videos. Sorry, I already had it open. I have some printouts. I'm going to go to the basic parent function. This is going to show us the basic graph of the exponential function. What we're looking at is the domain, negative infinity to positive infinity, so it spans the whole x-axis. The range, however, we can see this curve is flattening out along the line y equals 0, which is the x-axis. So this is our horizontal asymptote, it's 0. Now if there's a transformation, this goes up or down, that would change our asymptote. However, the domain will be the same. It will go from negative infinity to positive infinity. With any transformations, it won't change. So just kind of keep that in mind as we graph it. So we're going to use transformations. So right now we have 2 to the x plus 2. This plus 2 is kind of in the k position, which means there's going to be a vertical shift up or down. So this graph is shifted 2 units upward since it's positive. Next, it says the parent function y equals 2 to the x is it says decreasing, increasing. So I didn't see that other option. This is an increasing function. We can plot a few points. It says use and the horizontal asymptote from the outline of the transformation graph. So it says an example. If we plug in negative 2, we get 1/4. If we plug in negative 2, it would correspond to 9/4, and that's because of the plus 2 that got shifted. And so same thing, plug in a negative 1, we would normally get 1/2 on the original graph. The point on this graph would be 2 higher in that position. So in the same way, if we do 0, 1, I'm going to add 2 to this position. This will give me 0 and 3. And then it says the point 1, 2. So on this graph, so 1, 2, we're going to add 2 to the y coordinate. So this will be 1, 4. And then 2, 4 on this graph will correspond to just adding 2 to this position. So it'll be 2, 6. Got a green check. All right, so now we're going to graph the function. So we can plot some points. I could just use the pencil and plot these 3, 0, 3, 0, 3, 1, 4, and 2, 6. And then asymptote is going to be at 2. So it makes you put the asymptote. So the asymptote is normally 0, but because of this +2, it gets shifted up 2 units, and then it curves up through those points. Green check. We're going to write the domain and the range. So the domain, okay, is still going to be -infinity to +infinity. The range, however, it was 0 to infinity, but because of the +2, it's now going to be shifted up 2 to infinity, +2 to infinity. And then it wants us to write the equation of the asymptote. Well, it is a horizontal line that is y equals, and it crosses only the y-axis at 2, so it's just y equals 2, the way we write those. Y equals 2.